for those of you that can't remember, if you just listen, we've got F1 is 6th angle 25 degrees. The way you do that on your calculator is to push shift, then the rec, which is on the minus button, that's the shift function on the minus button, that will open some brackets. You then put in the number 6, then you go shift and do the comma, which is on the close brackets button, and then you put in 25 and you close the brackets and do equals. But you must also check, of course, that your calculator is in degrees mode. Right guys, what are the rectangular forms of these two numbers?
That's 3.
What's that? Where do I get 7? 3 angle, so that 6 angle 25 degrees is equal to, I want them in, what's x then? Go on. 4, 4 then, the 3 significant figures, plus 2.54j. Yeah? And the other one, 3 angle minus 25 degrees, 2.46, 1.72j. We just add them up column-wise to get an answer of. So these two added together, 7.90 plus 0.82j. And then we do the reverse conversion, so we do shift polar and put those two numbers in, and we end up with it back in polar form. Sorry? Yeah, and once you got it in polar form, yeah. Right, gents, sorry about that. That should read I is equal to Vs over Zt. Okay, so what we've got here is we need to add these two together. 3 plus 4j and 4 minus 2j. The answer to that is 7 plus 2j. Converting that to polar form, the answer is angle what? That 0.24 sounds like you got your calculator in radians to me.
That was 7.28.
7 angle.
7.28.
I'm going to go 7.3 with that. Angle 16 degrees. Yep. Okay. And then we can do I is equal to Vs over Zt, which is 24 angle nothing divided by 7.3 angle 16 equals 3.3 amps angle minus 16 degrees. Okay? All right, everyone? Yeah. Excuse me, somebody said. Who said?
I was just wondering how you would...
This current here is if that phasor, let's draw a nicer straight line, can represent this voltage and current using what's called a phasor diagram. Yeah? That red phasor represents the voltage V, 24 volts at 0 degrees. You'd represent the current 3.3 at angle minus 16 degrees. Yeah, and if you drew the waveforms, because the AC current, if we assume these are a sine wave, if that's T is equal to 0, your voltage would be like that, and your current would be 16 degrees behind it. That phase difference in there, 16 degrees. 16 degrees later in time than the voltage. Out of phase with each other. Okay? So that's what that kind of thing is all around. Right, the last little one I want you to look at is, do you remember, gentlemen, Kirchhoff's laws from electrical principles? Yeah, okay, there's a voltage law, voltage law, and there's a current law, right? Remember? So just going to have a little bit of a look at the voltage law. Kirchhoff's voltage law says these two volt drops here and here across these two impedances add up to the 24 volts that we apply. There's one loop in there, okay, and those two added together equals that 24 volts. So, using Ohm's law, calculate the volt drops V1 and V2. So V1 is the current I that you calculated times Z1, and V2 is the current I times Z2. Yeah, definitely. No. So do those two, okay, and then we'll look at the results before we go on and prove that. Okay? Yeah, you calculated that in the last question. That's the same circuit. Our current was 3.3 angle 16 minus 16 degrees, wasn't it? That's I. But what we are going to do now is we're going to need those two impedances in polar form to do that multiplication. Minus 16 plus 53.1. And this one, 3.3 times 4.5. 14.7. Angle. Minus 16 plus... Minus 16 plus minus 27. Plus 11, isn't it? Yes. Probably, that's what someone else give me. Point 1 ain't got to make a great deal of difference. Minus 16 plus minus 27. Plus 11 degrees. Okay? Right, guys, attention please. Remember what Kirchhoff's law says. Says those two voltages add together to make 24 volts. 15, nearly 16, and nearly 15, do they add up to make 24? No. But convert those two back to rectangular and add them together. Convert those two back to rectangular form and add them together. Add them together. So what do you get? What do you get for the rectangular number for 15.9 angle 37? 13.2. Come on. And the J part. Plus. Yeah, and then the other one, 14.7. Angle minus 43 is 11 something. 10.8 minus 10.0. Yeah, adding those together, and that's J. Add those two together. Is approximately equal to 24 plus 0J. If you allow for the fact that you've done two conversions between rectangular and polar and rounded them, okay, but that's close enough to say that circuit is compliant with Kirchhoff's voltage law. Okay? So, that concludes what I was going to cover on uses of complex numbers tonight. The remainder of your time can be spent working on the assignment. Okay? I'm here to help, and I'm going to feed back any remaining stuff from previous weeks. Take any work in that still do.